Right, this is episode 5, and this is purely for the benefit of my grandchildren and anybody else's grandchildren if they want to watch. The problem is I wanted to work on this with the grandchildren, but some of them live in Leicestershire and some of them live in Gloucestershire, and they can't all be here at the same time. So I'm going to show them on YouTube. It's quite easy, it's just a bit of engineering, and I hope you find it interesting. So here we go. It's to do with this. This thing here, look, it's a bit of copper tube, like a top hat. And this bit here is a bit manky, look. It's got a, see if I can show you. Oh, look, you can see it's damaged just there. And I could almost pull that off because it's been soldered and it's coming off. So I've got to make a new base for that. But what the devil is it? Well, I'll show you. Look, it goes under here. It goes there, and then you never see it. Right, you know how this works. You just boil water in an enclosed vessel and you make steam, and the steam expands and you get pressure, and you use that pressure for driving the steam engine. Okay, you know that. So, but when the water's in there, you've got water at that level along there, and you're going down the track, you're going chuggity 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 down the track, and it's rolling all over the place, side to side and everything, and all that water is slopping about. So you want to be taking the steam off above the level of the water, not below. Obviously you're going to get water, and you don't want water going through your engine. So they take the steam off of here. So that's your outer steam dome, and that's your inner steam dome, and then inside there you've got this tube. And this tube is where the steam goes down there and then through to the engine. And that's what it's all about. So this is the inner dome, and that goes like that, and that is supposed to be tight so the steam can't get out. But you can see it's just rubbish. So we've got to make a new one. So first of all, we refer to the drawings. Obviously, that's the boiler, and this is what we're after. It's called the steam dome bush, and it gives you the dimensions of it. And unfortunately, it's in inches because it's from 1965. Anyway, it gives the outside diameter, look there, as 2 inches. First problem is it's not 2 inches. It's only 1 inch and 5/8. Oh dear. Oh dear. And then if we look at this drawing, here's the dome. Hang on, let it focus. Come on, there we go. Here's the detail, look. But it says, hang on, where's my finger? There. 12 times 6BA on 11/16 PCD. No, it's 1 11/16 inches PCD. Get it right. Right, PCD is pitch circle diameter. 12 bolts, 6BA. 6BA is the size of the bolt. That's an old size as well, but we'll come to that. But there should be 12 of them. Oh dear, oh dear. We've only got 8. So we've got a smaller diameter ring. We've only got 8 bolts. So it looks like we're on our own. So we'll have to, we'll have to try and copy the old one then, won't we? Right, PCD, pitch circle diameter, is the diameter of a line through the middle of all those holes. And that looks like, oh look, those little marks are 30 seconds, then the next one's 16th, then 8ths, and that looks like 1 and 1, 2, 3, 1 3/8. That looks like 1 3/8 PCD. Anyway, as the drawings are different to what we've got, and we're not working to the drawings, we can use what units we want. So if we measure this is 41 point something, and if we measure between the holes, we get about 35.5. Obviously, I've already done this. Obviously, I'm just showing because I can't do this with the phone and everything. I mean, I'm not Superman. Anyway, so that's what it is. It's 35.5 millimeters PCD. So what we'll do is we'll draw one to test it. Otherwise, we're going to make a right mess and we're going to lose material. Right, first thing we need to do is a cross, any cross, just so that we're going to draw circles. So we need a cross to mark the middle of the circle. So we'll do a line. It says line, I can either select line or just enter, it'll do a line. So if I do a line, say from there up there, look, it can only go up, down or side to side. If I press F8, I can go anywhere. But I only want to go up there, so I'll do a line. That's my first line, and escape. And I want another line, obviously, to make the cross, so do line again. That little triangle selects the middle, the square's at the end, but the little triangle means that's the middle of that line. Good, isn't it? There you go. So that's that. Now if I select that, those blocks are grippers. And the clue is in the name. So if I can grip that, pull that out across there. Right, so now I have a cross. So now I can do a circle just for reference. So circle, click on that cross and pull out a circle. I can make that as big as I like just by clicking somewhere. But don't want that, we want it 42, didn't we? 42 millimeters. So I'll delete that, do a circle again, start there, and this is asking me for a radius. So we want 21. Enter. There you go. That's me 42 mil circle. Now the PCD was 35.5, so half of that is, do another circle, half of that is 17.75. Enter. There you go, there's my PCD circle. Now when we're lining this up, we're doing this to visually check it, so just to help me, if that's 42 and the thing's 42, it's going to be harder to see. So just to help me, I'm going to do one a little bit bigger. So I'm going to do another circle from the middle there, just a bit bigger than that 42, just to make it easier to line up. Right, now we need the holes, and the clearance holes for those bolts is 3 millimeters. So I'm going to do a circle of 3 millimeters over here. 1.5. That's 3 millimeters. I'm going to place that on the circle. So I'm going to move it. Move, M for move, and pick it up in the middle of the circle. Now that's still only go that way and that way and that way. That's because I've got F8 pressed. So I'll press F8 again and I can go anywhere. I'm going to put it just there. Okay? And to make it easier, I'm going to pull that away from there, just so that we can see it. Now I want to fill that in because it's going to be easier to see if it's a block, a solid block. So I'm going to go to hash, what we call hash. Look, it's making hashes everywhere. I'm going to press solid. So ooh, look, ooh. So I'm going to go in there, and I'm going to go in there. Right. So that's the hole, 3 millimeters. Then I'm going to select it like that. And the command that we use for making 8 of them in a circle is array, A-R-R-A-Y. So I'm going to put it in. There you go. Array. Now, polar, path rectangular. Polar, because I want it around this pole. Yeah. Specify the centre of the pole. Centre point of the array. Well, it's there, isn't it? It's there. Oh dear. We've only got 1, 2, 3, 4, 5, 6. And we want 8. So, what we do is select it. That has selected the whole array. And if I come over here, I don't even know if you can see that. Let me see. Hang on, I'll move the camera if you can't. No, you can't see that. Over the side here is the properties. And in the properties, whoops, it says items 6. I'll select that. And I put 8. So when I press enter, we get 8. So if I delete that, that's my circle. So I've got my ring of holes, I've got my outer of the dome, and then I've got another line just to help me line up. So already done it, haven't I? So then I need to print it out and try it with the steam dome. So there's our drawing. We need it to be 41.275 outside diameter, and those need to be 17.75 millimeters from the center. Edit. I've just realized that I didn't do what I was supposed to do. I drew this to compare the old one with. I've finished it now, so I'm having to redo this. No, I was going to demonstrate that I was going to use the drawing, which is what I did the drawing for, was to line those holes up like that to make sure that the holes were in the right position, which they clearly are. And these outer rings look to help me line up. So that was the purpose of that drawing, which I didn't show before, which I'm showing now. So there. We also need a hole in the middle, of course. I've measured it. That is 1 inch, 25 millimeters. But we need to fit that into it, and I've just measured that. That's 28.7 something, but we need it to fit in there. So we'll turn it out to fit that. Anyway, BA bolts. 6BA. Let's see if I can do this and show you this. Ah, look. 6. This says standard tapping drills. Right, quick explanation about BA tapping in general. This book is all about taps and tap sizes. And this is a tap. It's not for turning water on. That is a thread tap. That is. That bit. This is a tap holder. Right. So here's all the information that we would need, and it's just relevant. Right, 6BA we're dealing with, aren't we? There you go. Right, tapping drill, and it says BSI recommended 6BA 2.3 millimeters. Okay, so what that means is that somebody would have drilled these holes out at 2.3 millimeters and then used a tap like that to cut the thread in it. Not this one, because this is a 4BA. 4BA is bigger. The bigger the number, the smaller they get. So that's 6, and they go down to about 12BA, which are tiny little things. Anyway, where were we? 6. 6BA 2.3. Now, clearance, look. Clearance, it says 2.85. So that means that the bolt, a 6BA bolt, will go straight through the hole. That's the smallest hole it'll clear. So we'll round it up. It's 3mm, isn't it? We'll just round it because it doesn't have to be that accurate. The most accurate thing is the seal between those two surfaces, not the size of the hole. So we'll do 3mm. Okay? Get rid of that. So these need to be 3mm. Okay, so what do we do then? Here we go. Here's our piece of material. So we need a slice 3mm thick, because we want that 3mm thick. We need a hole in the middle of there to fit that tube in. And we need a ring of 3mm holes. So in what order do we do it? Do we slice 3mm off there, cut the hole in the middle and then drill the holes? Or do we slice through 3mm off there, drill the outside holes and then make the hole in the middle? Or what? Right, what we need to do is, while that's a big solid lump, we've got something to hold on to. So we do as much work as we can with that as a lump, and then at the last possible moment we slice it off. So I'm going to put this into the lathe because we need to mark the center, as we did with the drawing. We need to start from the center of there. So I'm going to put it in the lathe and mark the center. So here's my lathe. You've seen this before, I'm sure you have. And it's called a center lathe because it works on the center, and the center line goes between there and there. And if I put you down there, you are now on the center, or even on that center. Woo! Anyway, rest of this frivolity. This handle moves this carriage that way. This handle moves the tool holder there that way. And this one does the same as that big one, only on a finer degrees. Look, 0, 0.2. That's 0.2 of a millimeter, 0.4 of a millimeter, 0.9 of a millimeter, 0.8, 1 millimeter. So that's half a turn to do 1 millimeter. So 0.2, we can do 0.1, we can do a tenth, we can do, what's that? That's 0.02, surely. Yeah, 0.02 of a millimeter. Anyway, so this is a self-centering chuck, and I'm going to put the tool in there. No, I'm not going to put the tool in there. I'm going to put the piece of material in there. Now the first thing is that this is a bit wobbly, so we need it to be true in that direction. So I'm going to take just a little bit of the surface off just to make sure that it's actually true, and we're starting off with a flat piece of material. You can see how that's untrue. You see how the high bit is now shiny. Yeah, that's better.